students, once again welcome back for the continuation of chapter 5 in chemistry, that is atomic structure. Today we shall discuss about valency. For this you can refer to page number 69 to 71 in your textbook. Before I start this, I would like to recapitulate that we have done in previous class. As you know that chemical behavior of atoms. Chemical behavior of atoms are three types. First one, tendency to donate or to lose valence electrons. Valence electrons means electrons present in the outermost shell or the orbit of an atom. Second one, tendency to gain or to accept electrons. And third one, tendency to share the valence electrons. Metallic atoms, they have 1, 2, 3 valence electrons. Valence electrons means electrons present in the outermost shell of an atom. So metallic atom, they have tendency to donate these valence electrons and acquire stable electronic configuration of the nearest noble gases. Here, stable electronic configuration means the outermost shell completed with octet, except helium. All the noble gases, helium, neon, argon, krypton, xenon, and radon. Except helium, all the noble gases, they have outermost shell completed with octet. They have 8 electrons, and helium has 2. And non-metallic atoms, they have 4, 5, 6. Or 7 valence electrons, and they have tendency to gain or to accept electron and acquire stable electron configuration of the nearest noble gases. Non-metals, they have tendency to share their valence electron. Here in a molecule of non-metals, here each atom, they mutually share their valence electron, and combining atom acquire stable electronic configuration of the nearest noble gases. Now let's move on to today's topic here. Valency. Valency is the combining capacity of an element, or it is the ability of an atom which chemically combines with other atoms to form a compound. Or valency is also defined as number of electrons lost by an atom or the number of electrons gained by an atom is equal to their valency. Now next here, electropositive balancing. Here, the atom that donates electron is said to have a electropositive balancing. As you know that metallic atoms, they have tendency to donate or to lose their valence electron. That is why metals, they are electropositive or they have electropositive valency. For example, here sodium, its atomic number is 11 and its electronic configuration is 281. Its outermost shell of the sodium atom has 1 electron. As I already explained you, metals, they have 1, 2 or 3 valence electron, and they have tendency to donate their valence electron. Now here, this sodium atom loses this valence electron, minus 1 electron. You see, minus 1 electron loses, and here acquires stable electronic configuration of the nearest noble gas whose electronic configuration is 2A, and this sodium atom forms sodium ion by the loss of its valence electron, and possesses one positive charge which is known as cation. So here the valency of sodium is 1 because it loses 1 electron. So here sodium has electropositive valency. Valency is plus 1. Now next here, electronegative valency. The atom that accept or gain electron is said to have electronegative valency. non-metallic atoms, they have tendency to accept or gain electron, and they have electronegative valency. For example, here chlorine, its atomic number is 17 and its electronic configuration is 287. First cell accommodates only 2 electrons, second cell 8, 2 plus 8, 10, 17 minus 10 is 7. So its outermost cell has 7 electrons, so chlorine is non-metal. And this chlorine atom needs 1 electron to acquire stable electronic configuration of the nearest noble gas argon. So your chlorine atom has a tendency to gain 1 electron plus 1 electron. After gaining 1 electron, it possesses or it acquires stable electronic configuration of the nearest noble gas argon, whose electronic configuration is 288 and possesses 1 negative charge. Iron having negative charge is known as anion. Here, take a chlorine atom, gain 1 electron, so its valency is 1. So it has electronegative valency -1. It gains 1 electron, so its valency is -1. As I already explained you, number of electron lost by an atom or the gain by an atom is equal to their valency. Here chlorine gained 1 electron, so its valency is 1. It has electronegative valency -1. Now next here, variable valency. Now what is variable valency? If an element has more than 1 valency, then that element is said to have a variable valency. Most of the metals, they exhibit variable valency. Once again listen here, if an atom has more than 1 valency, then the element is said to have variable valency. Most of the metals have variable valency. Example here, iron has 2 valency, 2 and 3. For variable valency, we'll use suffix OUS for lower valency and suffix IC is for higher valency. Here, iron exhibits variable valency. FERROUS, ferrous, OUS, suffix is OUS. And the symbol of iron is Fe. Here, suffix is OUS. This is used for lower valency. Here, ferrous valency 2. And ferric. Here, suffix is IC. This IC suffix is used for higher valency. Ferric, the symbol is Fe and valency is 3. The symbol of iron is based on Latin name, that is ferrum. Similarly, copper has more than 1 valency. It has 2 valency. Cuprous valency 1, cupric valency 2. Mercury, gold, tin, lead, they have variable valency. Now next here, radicals. Now what are radicals? A radical is an atom or group of atoms which behave in the manner of positive or negative charge. They have their own symbol or formulae and combining capacity. Here, radicals is an atom. See, these are atoms or group of atoms. These are group of atoms, sulfur and oxygen, carbon and oxygen, nitrogen and oxygen. Your fluorine atom, your group of atoms, nitrogen and hydrogen. Here once again, radical is an atom or group of atoms which behave in the manner of positive or negative charge. They have their own symbol and formulae and the combining capacity. These are combining capacity means valency. Here, next your types of radicals. There are 2 types of radicals, basic radical and acidic radical. Basic radicals are also known as cation and acidic radicals are also known as anions. Now, what are basic radicals? Radicals having positive charge. Radicals having positive charge are called basic radicals. Example here, sodium ions, sodium ion, calcium ion, ammonium ions. See, radicals having positive charge are called basic radicals. Now, acidic radicals. Radicals having negative charge are called acidic radicals or anions. See here, chloride ion, nitrate ion, carbonate, valency 2, sulfide, valency 2, sulfate, valency 2. Here, these are the radicals having negative charge. And they are called acidic radicals and the valency 1, 1, 2, 2, 2. Here, dear children, here we have come to the end of today's online class. Thank you very much.